How are
Hey,
you?
good, good. How are you?
Yeah, I'm good. I just feel tired a little bit physically because we went to a hike yesterday.
Uh-huh.
I hope my brain still can work.
Okay, great, cool. So based on the topics you mentioned, you like to get a hard problem?
Yeah, I like to try hard because I don't know what kind of question I'm gonna get in the real interview,
Hmm.
so I just want to try to feel comfortable when I get a hard question in the real interview. I
Okay,
may not be able to solve it, but I will try my best, I would say.
okay, sure.
Yeah.
Great. Then we can go to the code bank and then let's try this out.
Sure.
You can choose any language. Are you using Python or?
Yeah, I use Python. I prefer Python first.
Wait, let me get the questions out here. This one has a lot of things to read. Let me give the lead code link on the top as well. So if you have hard time to understand the problem, then feel free to go to the lead code. So they have visualizations, graph to
Oh,
help
okay.
you to better understand.
Okay. You shared the link or?
The code bank link is in the up level, the same place you get the link.
Oh, okay. Okay. Just let me check. I don't see. Oh, I see. It's there. Okay. Given the address of a directed graph where address the address from AI to BI indicates where is an edge between nodes A and B, and the two nodes source and destination of this graph. Okay, determine whether or not all paths starting from source eventually. Determine whether or not all paths starting from source eventually, and at the destination, that is. At least one path exists from the source node to the destination node. I think I will open the
Yeah,
leak
yeah,
code one. Like you said, they have a graph.
yeah.
Help me.
They have visualizations, easier to understand.
Okay. Source destination, source destination. So the questions are same, right?
Yeah, yeah, the same thing.
Yeah, I'm reading the lead code page.
Sure.
So yeah. So source to the destination node. If a path exists from source node to a node with no outgoing address, then that node is called to destination. The number of the possible path from source to destination is a finite number. Return true if and only if all roads from source lead to destination. Oh, okay. 3 edges. Okay, I will explain what I'm thinking after I read this question. So first of all, this is a graph question, and it's a directed graph, right? And we're trying to see from the source to the end, and if all the paths between source and the end can lead to the destination, right? So which means if there is a cycle in the graph, then this is we should return false, right? Because return false, because if we go into that cycle, there's no way we can come out. We'll keep looping there, right? This is one assumption. A second one is, so each path has to lead to the destination. The example was, are you able to see the lead code graph? Because they have example 3.
Yeah, yeah, yeah.
So
Yeah.
yeah, so the example 3 returns true. But if we remove the link between 2 and 3, then we should return false, right?
It should be
Am I
still
correct?
true, I think.
Supposed to be true. But the question is says, or at least one path exists from the source code to the destination node. Okay, if path exists from source node to a node with no outgoing address. If a path exists from the source node to a node with no outgoing edges, then that node is equal to, oh, I see, is equal to destination. Okay, so but for the example one, the source is 0, destination is 2, and we have a path from 0 to 1 and 0 to 2, but it returns false, right?
Mm-hmm.
Um, so why this one return false? It's possible to reach and get stuck on both node 1 and node 2. We have 3 nodes, 0, 1, 2, and the edge 0, 1, 0, 2, source is 0, destination is 2, return false. Can you help me to understand the example one? So the source is 0, destination is 2, right?
Mm-hmm.
And we do have a link between 0 and 2, and then that is the directly connected link
Mm-hmm.
between 0 and 2. So which means we can reach 2, but
Mm-hmm.
we still return false because if we go to 1, then we stuck there. Is that correct?
Yes. So in that case, it's a false.
In that case, it's a false, but based on the description for the second condition, if a path exists from the source node to a node with no outgoing edges, then that node is equal to destination. Is this one saying that if we don't have outgoing edges from node 1, so we can think node 1 is destination?
The destination needs to be based on the input.
What do you mean based on the input? Oh, based on the input, I see. So okay, we still have to go there. So then, which means for the example 3, um, if we break a node between 2 and 3, then we should return false, right?
0, 1, 0, 2, 1, 3. In that case, yes, that'll be false. Yes, right.
Yeah.
Yeah,
So
I
which means
was wrong earlier. So
yeah. So which means yeah, I see. So which means I need to first detect if there's a cycle. If there's a cycle in the graph, I need to return false. And the second, I need to go through all the passes to check if I can reach to the destination. I want to, maybe I can share my screen. I just want to um
yeah, you can share your screen and then directly do that in the LeetCode. So that's totally fine.
yeah.
Or in whiteboard. Yeah.
Yeah, I am sharing my whiteboard. Can you see it? Because
Okay.
I want to completely understand the question. I don't want to code it out and later see that I didn't fully understand the problem.
Okay, sure.
Yeah. So I have let's see, I have a 0, 1, 2. Oh, sorry. Are you able to see my
Yeah, yeah, I can see that. Yeah.
Okay. So let's see if I have this one connected. 1, 2, 3. So this is example 3, right? What I'm drawing now. So
Mm-hmm.
this one I need to I should return true. What if I have another link to here,
Mm-hmm.
right? Now I need to return false because if I go to 2 and then go to 4, I cannot reach 3, right?
Right, right.
But if I have another one, this one, and then I need to return, um, I would say true, right?
Yes, yes.
Yeah. And will there be a duplicated duplicates? I mean, I would say if there's a from 2 to 3, like
Yes,
this one,
it's possible.
it's possible. But this one actually it doesn't matter. I because we go to 3 also. Um, so I see. Okay, and this one, what if this is the graph? From 3 still have outgoing edge, and this outgoing edge going to 1, there's a cycle,
That
but
return false.
I should return false. But
Mm-hmm.
I can reach. Oh yeah, but oh yeah, I see. It should return false because but from every edge I can reach to 3 because I may go from this way. I would say. Um.
Now you need to look at the question itself.
Uh-huh.
Uh, the, the, the number of possible paths from source to destination is a finite number. That means
I
it's
see.
not unlimited.
I get it. Okay, I see. Okay. Okay. So yeah, so far I'm thinking break this question to 2 parts. One is detect a cycle in a directed graph. Um, so which means is try to see if a graph is a DAG, right? That is the first thing. And the second thing is if it is a DAG, then we need to walk through all the passes and check if the destination is reachable from all the passes. Because I have to exhausted all the passes, right? Yeah, I have to exhausted all the passes. For the first part, I think I know how to do it. There are the first question I know how to do it. I'm thinking about the second one, how to go through all the paths, because I don't want to traverse graph twice. I'm thinking, can I just traverse the path once and get the answer? So which means um so from 0. Oh, maybe let me still do this way. Let's break. Um, I will break the question to 2 parts. One is how to check if there's cycle. For that one, I think I would just check. Um, I will just use arrival time and a departure time. So this is uh, directed connect graph. So I need to check if there's let me see. Just 1 second. I want to change the color of my pen so that I can. How can I change color? Okay, so if we have another, let's see if the destination is 3, and we don't have this one. We don't have this one. So this edge from 4 to 3, that actually is a cross edge, because I may go to from 0 to 2 and to 3, and 3 is visited already, and from 0 to 2 to 4 to 3, but the 3 is visited already, but it doesn't mean that it's a cycle, because this is a cross edge. It's from another node to this one. What if I have another link like this? So I start from 0 and I go to 1 and I go to 3, and I go back to 0 and I will visit this 3 again because I have a link between 0 and 3. But that is also fine because this is a forward edge. In the DAG, forward edge add a won't add a cycle. So then I'm thinking only the backward, the back edge will create a cycle. So which means if I have something like this, then this is a cycle. So now I will start assigning. I will use the departure and arrival time to solve this problem.
Mhm.
Um, but actually, for detect the cycle, I don't really need arrival time. I can just use the departure time, because which means, let's see, if I start assigning times on when I just 1 second, when I visit a node. So let's see, if the departure time of this one is 0. Oh, no, no, no. So what I'm gonna say departure time is that I visit all its neighbors and come back and go to and leave from this node. That's departure time. So when we come into this node, there's no departure time actually. And I come to this one, there's no departure time. And I come to this one. Since this is there's no outgoing edges. Let's see if I don't have this link, and then I will go back. So the departure time for this one, I will say I assign number. I will say like 0, and then um I will go back to 1, and this one the departure time is 1, and this one is 2, and I will number all. I mean, um traverse all other um nodes. So this is fine, because this is if I remove the green one. But the problem is that if I have the green one, okay, the problem is that if I have this green one, then then there's gonna be problem, because I don't have a departure time, which is nothing, nothing, and I go here, I assign a number like 0, and this one have a link back to this node, 0. And then this node is already visited, because is the source. And then I will check the departure time of this one. If this one is already visited and it doesn't have a departure time, I will say there's the cycle, because this is a package. So this is how I detect a package, which is a cycle in the graph. Um, right. So this is gonna give me part of the answer of the question. Um, This is the one condition I need to check. And then the second condition, oh, okay. Actually, before this one, I would say Redis here. Cycle. Uh, the second one, I cannot have separated. I can only have one components, which means I cannot have another like two components or something in the graph. Let's see if I have another one, 5, 6 here. Though there's no cycle, but definitely this one cannot reach um uh, the 3. So this is also not a correct answer, right? I have just have a um one component. I would say one component. And the second one, sorry, and then the third one, I need to check if all the paths that I can go to I can reach to the 3. So if I just use this two, check this two thing. I'm thinking third one. For the third one, from 0 to 2, 0 to 1, 3. Because for this two, if I see there's a separate component, I would return false. This one I would return false, and then I won't be. I don't need to finish the traverse for the whole graph. Okay, let's see now if I finish the traverse. Cause let's see if I don't have this one, and I don't have this. I just have something. Okay, make it shorter, easy to understand. Let's see if I have something just like this. I don't have this forward edge. Remove this one. So I start assigning. What I'm thinking is now is I'm thinking, can I just do one tra uh, graph traversal and answer get the final answer? Because I could do one traversal to finish first and the second. I'm thinking, how can I do the third check? Third check is for all paths can lead to 3. Let me write it down. Okay, this is O path. O path can get to 3. I'm thinking, how can I do this along with the same traversal for 1 and 2? 3, because I will start assigning number. Let's see, departure number is 0. This one is 1, and we go to 2, and go to 3. 3 is visited already, so we'll come back. And this one departure number is 2, and this one departure number is 3. Okay, so whenever we reach to the end, we will return. So which means I just need to keep a temporary array that keep all the let me see. Keep all the nodes along the way. Do I need to do that? But if I do a DFS, so I always go to the next one, the deepest one. So I may just need to put a check in my DFS function to see if I reach the. Yeah, I think I may not need to keep anything temporary array. I just need to do this. So in my DFS, in my DFS function, I will just visit all the neighbor. As long as I have a neighbor, I go and check it. And after, this is kind of like post order traversal, right? After I come out from all the neighbors access, this is all the neighbors access. I check if if 3 is reached, right? Because this 3 has to be the destination. We have to go all the way down to 3. So I will after this is done, I will just say if 3 reached. If 3 is not reached by any of my children, or I am not the 3, then I'm gonna return false. So which means I cannot reach to 3. Yeah, I think that will work. Yeah, that's so far what that's I'm thinking. I don't know if you're okay with my algorithm.
I'm totally okay. Yeah.
Okay. 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 Now let me let me write the code here. Oh. Oh no. To be honest, I haven't used this IK code bank. So for IK code bank, can I run my test case, or I
Yes,
cannot run?
you can still run. Yeah. You can use the LeetCode editor if you like.
Oh, but for the code bank, they don't have a test cases, right? Not like a LeetCode. LeetCode they can verify my
I mean,
code.
you can use the LeetCode to do this problem as well.
Sure. Then I will use LeetCode, and then I will share my screen. Then you can see how to share. Stop sharing.
Yeah, let me just do that in a LeetCode then.
Yeah, I will share my desktop.
Mm-hmm.
Just 1 second. I have many windows. I'm thinking which one to share. Can you see this one? This is the question.
Yeah.
1059, right?
Mm-hmm.
Yeah. So again, I will say that I'll use DFS because for directed connect graph and to check a cycle, it's too hard to use BFS. I haven't done that yet, but I prefer DFS. Are you okay with that?
I'm okay, yeah.
Sure. Okay, then I will start. So like I said, I need to check the departure time. So I will first the departure I will give this -1. I have n nodes. For each node, I need a departure time. Do I need a parent? Do I need to check a parent? This is a direct graph. Direct graph, I don't need to check parent, so I don't need that. But I do need to see if this one is visits or not. So visited, I need a visited structure. To assign departure time, I need a timestamp. Okay, I will start with 0. And what else do I need? So far, I will keep this. I may need more. I will add it later. And then I will say this is my DFS and start with the node. So for the DFS, when I see the node, I should capture the node already, right? Do I? Because this is just DFS. Yeah. So whenever I get a node, I should mark as visited node as I have visited this node, and I don't need a arrival time. I only need a departure time. So I will departure time node time stamp, and then I'm gonna increase my timestamp. And for this one, I can just need to return true or false. If I can get to the destination, I will just return true. Otherwise, I return false. I will handle the false. Probably I need to add some check here for the false. Okay, I will say that. I will say. Actually, it doesn't matter before the departure or after. Okay, I will put it here. Was condition. Okay, I'll put it here. I will add a code later here. And then now there is as it with its neighbors. Let's see, neighbors. Okay, and it gives me the address. I need to build the agency list first. I will use adjacency list for this question because I don't think the agency list to me is the best one because I don't think I need an adjacency map. I will just build adjacency list for this one. For the list node to the neighbors. So what can I do here is for this address a and v. I will just do this. So now I have my adjacency list. This is a directed graph. I don't need to build the edge from v to u. I only need it from u to v. So this is done. Okay. So now I get a neighbor in list. Yeah. Node. Okay. So if visited node is not been visited yet, and then I should just go and visit it. Okay, I will just put this here. Okay. But this one I'm gonna return true or false. If this return true, I keep checking if this guy return false already. Okay, and then I don't even need to keep doing anything. I will just return. Else, here is I need to check the departure time. So for the departure time, I will say um, else, so which means this node is visited yet already, it is yet captured and visited. Oh, sorry, it's already visited and captured. So I supposed to have, I need to check the departure time for the neighbor. Okay, if departure neighbor minus one, because I give the initialize the all the values to minus one, which means it's um it's not been done yet. If it is not done yet, and then I return false, because I saw here is um back edge cycle detected. Okay, and then now I come here, so I need to check if the if I from me I can reach to the destination. How can I check that? Because I'm node let's see if I'm node 0 or I'm node 1. How can I know that I reach to this guy? Damn. So one way to do is that I give global variable. I don't want to use a global variable. Looks oh, do I still have time? I have to finish this. Okay, I will just do this. I think this should be fine. If node yeah, I think so far I will use I will return two things. One is the first one is no cycle, and then this that's the font. I will do something like this. It looks a little bit like clumsy, but I will do this first. I will see if I can optimize it later. Because this one I will do false. If it is false, actually it doesn't matter. I can always go false. If it is false, I don't really care. Let's always do false. Right? Am I right? Okay. And I need to check this one. To capture this one. This is cycle. So I cycle, and this is list found. This way then. No cycle. Okay. Else, there's no cycle. Okay, no cycle return true, And then if that, yeah, this code looks not clean to me. True. Okay. Code is I will just do that like this. So, no, I cannot return truth. Yeah, suck. Sorry, I have to false. False. Okay, alright, and then I come here. So I think that's it. Isn't it? No. So if it is not found, it is no cycle, but we haven't found this guy. If there's not a there's no cycle, no. We have cycle. We go here. We don't have cycle, but I didn't see this. Everything false. Oh, I think this one should work. Let me see. What is destination? But I didn't check the destination. Huh? How come though? Okay, I have to check. Okay, node to return true. Well, actually, I can just return false. I don't need to do this. Okay. Yeah, the code looks weird because this is true. I think I can remove this. But let me try this further. Oh, this looks weird. Okay. Yes. But I will just run one test. I just want to check if I have like typo or my code can run. What's wrong? Oh, okay. Yeah, it works for this one. But may I ask? I will only get one question, right?
Yes, only one.
Okay. Then I will spend some time to clean my code a little bit. I don't like it. I don't think I need this. The thing. Well, I will keep a copy. Just copy paste the whole thing, cause I got a kind of working code, and then I give it there. I think the initial I think this should work. Don't need to do that. Yeah, cause if we get false, we return from there already. Anyways, cause this one will do the magic. We'll check the destination. Okay, I think it should work. I don't need this. I can just return. I don't even. Okay, it works. Okay, so then let's return this guy. I don't even need this. Then. Okay, it's much better now. And back to what I have before. Oh, this one. What else can I make it better? I think it's clean enough. With this one, it should work, huh? Whoops. Oh, miso colon. Oops. Oh, yeah. Okay. I don't mind. I just submit to run the full test cases, or you want me to manually cover some edge cases first? Cause it's gonna take more time if I just manually do some test cases, edge test cases.
We don't need to do that. We can submit and see what's missing and
Oh,
let's
okay.
fix
Okay.
the
Cool.
bug there.
Yeah. I'll just do it. Ah, wrong answer. Damn. Why? Maybe because I missed. This is I missed the first one. This one. No, there might be some unvisited nodes there. Okay. Let me draw this one. Okay, just let me check. We have a 4 nodes 0, 1, 0 to 1, and a 0 to 2, 1 to 3, 2 to 3. Oh, how come I return false? 0 to 1, 1 to 3, 0 to 2, 2 to 3. Oh, I see the reason. The reason is that the 3 is already visited, so I need to change this a little bit. Else. Yes. Okay. Should return true. This one work? Okay, let me see. Still not working. I think I missed one thing here. I need to add one more thing here. I need to do this. I need to check the node for node in. You cannot just return for purchase. In with it. Yes. Right. This one I need to do. Do I need to? As I return this one. If it is false, I should just return. Yes. And then I check this. This covers the separate components problem first. Okay, and then this one, why it is not working? Let me try if I break anything. I didn't break anything. Oh, who returned the I need to print it here. This is cycle. This is true. This mode. Oh, just do this. Let's see what's going on there. Cycle. There's no way why there's a cycle. 013 01 02 13 23. There must not be a cycle. Departure time. I do this after all the visit. And minus gonna give it. The neighbor is already visited. Which one? One. Neighbor is one. Okay, let me print the node also. What is node? 0. Okay, interesting. Let me print the adjacency list. Oh, I don't have enough time now. 1, 2. I give -1, huh? Give -1. Why it's not working? This is node -1. If not, like this. Departure. This is cycle, and the neighbor is 1. How come when come back to the neighbor is 1? How come? We should come here first, huh? The node is 0. Yes. The neighbor is 1. Oh, okay. Okay. Still is wrong. Yeah, here. Now, here the problem. Yeah, here's the problem. But then I should come here if there's 1, M1, and the departure time is neighbor M1, 1 get to 3. So the neighbor is a 3. The neighbor is, no, we visited the neighbor already. But the departure of the neighbor is not there. Come here. If the neighbor equals that, we return true. We should return true here. Oh yeah, we return true, but I still come to here. Oh no. Well, looks like I need to come back to this one. Then neighbor destination. True. Okay. Interesting. We should come here. We don't come here. We should come here. Interesting. Why is like that? Oh, because we come here. Oh, because this guy returned true. Okay. Oh, man. This one should work, huh? How come? Yeah, this one should work. Because I get node, neighbor is 1. Yeah, neighbor is 1 and neighbor is 3, node is 1. We return true. But if it is true, we return true. This one should work. Why it's not working? So let's that. Remove this. See, I don't come here anymore. 3. 1. Where do I return false? I don't see the cycle. This one I can come here. No, I didn't come here. The cycle. Destination 3. This one is correct. Node. Why am return false? Here, because of this guy. Oh yeah. Okay. Let me clean this one. Clean this one. Clean this one. Just let me check why I'm having a problem here. Node image reset. One 0 1 2 3 0 1 2 3 2. Really? Let me try this one again. Yeah, definitely it's not working. Let's see, 2. This one. Oh, I didn't even reach 2. Why? I don't even go to 2. Oh, I see. Oh no.
We don't have much time left. I think you are very close. Just
Yeah, I think I know the problem because I shouldn't just return here. I need to finish the loop. I cannot return true directly. These two
you
conditions.
have some global variable somewhere to
Yeah, I have to have a global variable somewhere because if I return true, I'm gonna bypass the second path. Yeah, so that's supposed to be answer. I need this one. I need to put this one back. The check back. I don't need this. Yeah.
Okay.
Yeah. Something like that. I need to finish the for loop, and then if everything is fine, I return true. Otherwise, I should return false. Yeah. I think that's the part I'm missing.